This time we have Professor Wassim Jabi, who is the course director of the Masters in Science in Computational Methods in Architecture at Cardiff University. His extensive research spans parametric design, building performance simulation, robotic fabrication, leading to notable publications and projects, including developing the Topologic software library, which is what he is going to talk about today. Welcome, Wassim. How are you?
Good, good. Thank you for having me.
Thank you. Let me bring your slides and the stage is yours.
Oh, great. Thanks. All right. Thanks everyone for attending. I'm really, really excited to be here and talk to people who know about Speckle and how it can help your processes. So today I'm going to be talking about topology and how it is important, and a piece of software that we have been developing for a long time called Topologic and topologicpy, which is the Python bindings for it. And in particular, I will show a quick demo of how we have leveraged Speckle to connect to Pollination Cloud to do energy analysis directly from models that have been uploaded with Speckle. First of all, I always start my presentations with acknowledging the team that worked on the original grant. So in 2016, we received a grant from the Leverhulme Trust for £300,000 to enhance the representation of space in building information modeling. And this resulted in the creation of the Topologic software library. And since 2019, I've been developing Topologic and topologicpy continuously at Cardiff University. But obviously, the original collaboration was with Professor Robert Aish from UCL, Simon Lennon from Cardiff University, Katerina Khatzi-Vasiliadi from Cardiff University, and Nicholas Mario Wardhana, who was with us as a research associate. He left the project when it concluded, and I believe he is now in Japan. So what did we tell the Leverhulme Trust about? We basically told them that there was this promise, and then there is a problem with that promise. And we all know that who have dealt with BIM. Building information modeling had great promise and is delivering on a lot of the stuff that we wanted it to deliver on, but the process is still broken, unfortunately. From my perspective, from our perspective, in terms of what we wanted to tell the Leverhulme Trust about, is that BIM data is often incomplete, it is unstructured, sometimes it is unconnected, and sometimes it's ad hoc. But what I mean by ad hoc is that it does not always contain the information that you need. There's no standard for it. And sometimes that information is badly formatted, badly kind of included, and badly connected to other information. So you cannot rely on it. And that is something that we want to solve. Obviously, Speckle has been solving this by saying, we don't exchange files. We have an API that kind of delivers objects that have proper attributes, and you can rely on them having those. And you can ensure quality of the data that you are exchanging based on APIs rather than on files. So that's how, obviously, their type of thinking meshed with what we are thinking. And that's why we decided to integrate Speckle in Topologic. But going back to what we are proposing as an alternative methodology, we would like to impact actually the architectural design and development process to encourage architects and designers to design a succinct but semantically rich conceptual model. And I would add to that maybe perhaps a topological model, meaning that entities in that object are interconnected, are linked together. And and then once you do that, you analyze those relatively simple models, geometrically simple models, but they are topologically sophisticated, and they are full of information that enables you to analyze them to ensure quality, efficiency, sustainability, and value. Once you are done with that kind of iterative process of building these models, generating them, and perhaps AI and generative methods can help you with that, and Topologic obviously will be helping you with that, then Topologic in combination with really advanced scripts and AI and machine learning can automatically and intelligently convert those to fully detailed BIM models. If you've heard me talk about Topologic and BIM before, I always say Humans should not be wasting their time putting conference chairs in conference rooms or figuring out where the windows should go, etc. We have a long tradition of knowledge that we don't encode. We should encode in our kind of processes. And AI and software is much more adept at populating and generating BIM models from very rigorous conceptual models that capture design intent. And this is kind of one of my kind of pet peeves, basically, is that these BIM models, as sophisticated as they are, don't always capture design intent. They capture design form, information, but they don't tell you that the architect wanted an L-shaped building or wanted a symmetric building or wanted always the dance floor not to be on top of a quiet space like a library. These design intents are not captured, and we need to be able to capture them. And I believe we can capture them by a combination of geometry. Of course, we cannot get away from geometry. We need it, but also topology, how things are connected to each other, what should remain connected to each other, and then semantics and information that carry all the other non-geometric, non-topological information that is also needed. So just some use case scenarios. We have been working with a company, a large company in Germany called eProConsult in Dresden. And what we have worked with, especially with Ahmed Al-Tahlawi and his team, is to take test fit models. This was early on, before TestFit did their own plugin. So we were the first to do that, where we took test fit models and through Topologic, captured those models and converted them into well-connected topologies, and then imbued them with all the information that's coming in from the test fit files, and then converted them automatically to Revit files. Obviously, they have their own plugin right now. We're really happy. We have worked with them for a long, long time, and I think it's right that they have now included that kind of converter in their software. But we take it a step further with TestFit in the sense that we can build graphs behind the scenes of these buildings, and we can detect rooms that's supposed to belong to each other, like say in an apartment. In this case, this has been applied to a student housing project. It's a 20 million euro project that's now complete and constructed that used Topologic to kind of optimize distances and optimize daylight. But also because we have this topology, we can tell which rooms need to be linked together, and therefore we can automate all sorts of schedules and color coding that you need to do in Revit. The other use case that is really interesting is in the area of Open BIM. So what you see at the bottom is work by Bruno Pothel, who is a really good friend. We met online. We haven't met him in person ever, but as this thing is usually. In that case, this is done in Blender BIM, and Blender and connected to Blender BIM. And Topologic works also in Blender because it's a Python library, so it can work in different environments. In that case, he takes a cube, a very simple cube, which we call in Topologic, we call it a cell, slices it with planes, we call those faces, and just through that kind of slicing, we build a divided volume, which we call a cell complex. And based on rules, with one click of a button, he converts it into a fully ISO-compliant IFC file with all the windows, all the cornices, all the doors put in according to those rules. And it even has an embedded energy model inside of it based on the original Topologic model. And that's all free, open source, available, so it's really powerful. Again, if you have heard my talk before, I always talk about complexity last, not first. So basically postponing complexity to the very end, just to kind of make the point that complex data, like what we have in BIM models, sometimes prevents you from doing the important analysis that you need to do. And this is a case where Kevin Crump, also known as the BIM guru, he created this kind of typical hospital wing of some sort, and it's available. It's also open source. You can download it and you can analyze it any way we say. You can use it as a test case. But in order to do the kind of analysis that Topologic is good at, like, for example, shortest distance for egress or isofist, like where does the nurse station, what doors does the nurse station see or not see, visibility graphs and all of that, you need to actually peel away a lot of the irrelevant information in your BIM model in order to get that analysis done. So more information is not always better. So we think that all of this type of analysis that's really important and can tell you a lot about your design and give you a lot of insight should be done on geometrically fairly simple models, really, but models that are not kind of dumb, excuse the word, but sort of like they are topologically and semantically rich. So Topologic has been connected to a lot of platforms, a lot of ecosystems, a lot of environments, and you can see most of them here. We have connected to Speckle, obviously. We've connected to Pollination. We've connected to Blender, Revit, Dynamo, Grasshopper, Rhino. Of course, the Ladybug tools and Honeybee tools are all there. But also one of the main kind of uses for Topologic is that it builds really good energy models that can be simulated very easily with OpenStudio and Energy Plus. And obviously, that allowed us also to go to Pollination very easily because we're reusing some of the methods that we have that enabled us to use Ladybug and Honeybee before. And now we are combining that with our OpenStudio expertise and doing all of that. Topologic is free and open source forever, as you probably have heard me say before. It also runs in Blender and Sverchok, which is a kind of a clone of Grasshopper. It connects to IFC, and I'll show you just a little bit of a sneak peek at the end of how we are dealing with IFC and graphs. But just to talk about topology for a second, topology delves into the intrinsic nature of spaces, emphasizing that the true depth of our world goes beyond surface-level shapes. It reveals the intricate web of connections and boundaries, serving as a reminder that reality is not solely defined by tangible form, but also by the intricate interplay of relationships between them. So it's not just the geometry, it's not just what you see, not an image of it, but also how these things are connected and all the information. And I think that resonates with what Speckle is trying to do in the sense that it's not just a file, it's not just the geometry, but you have an API that, it's an intelligent object that you can ask it a question and it can reply and give you the information that you need. Just very, very quickly, I know we are very short on time today. This is the kind of stuff that Topologic is really good at. In this case, it is abstracting a building into its spaces. It's building a graph, what we call a dual graph. Those are the red dots and the edges that you see inside the building. It does that automatically based on adjacency information that it builds from the geometry. And then it can do analysis. In this case, we're doing a space syntax type of analysis where every space, every room gets a color code based on its centrality measure. And centrality measure is very simple. It's basically the shortest distance from that point to every other point in the graph. And you average that or you total it and you give a score to the building. That tells you which buildings are remote, which buildings are more central. So in this case, it's color coding and detecting automatically, even though I did not tell it it's a corridor or it is an atrium that is central to the building, but it detects that through its centrality measure. So you see that the corridors get the same color, more isolated spaces are darker red, more central spaces are lighter color, and obviously this atrium is also identified. So Topologic can take an object and decompose it into its elements. That's not very unique. A lot of systems do that. So we can get the cells, we can get the faces, we can get the edges, we can get the vertices from a cell complex. But also, what is unique about Topologic is that you can climb up the tree. So from a vertex, you can ask that vertex which spaces use you, or which faces use you, or which edges use you. You can ask a space which cell complex uses you. So you can climb up the tree and do compositional topology. You can also, behind the scenes, build graphs, and those graphs are built, as I said, automatically, and they have a lot of options to them. This is just a sample of the outputs from a cell complex, from a building, into a flattened graph, whether it is in a radial or spring layout or a tree layout, depending on what the graph is. You can flatten those graphs, and the graphs and the graph nodes contain all the information from the original entities that they represent. So you don't lose that information when you go from a building to a graph. So this is the graph again. In this case, we are connecting to windows and to exterior topologies, exterior faces, and it's fully three-dimensional. There's no limitation on 2D or 3D. And as I said, you can see that the nodes are color-coded because that information is still in there, fully rich in information. Lateral topology in the sense that in the cell complex, I can pick a cell and ask it to give me its neighbors. So it can immediately give me neighbors. And you can imagine, if you know about energy analysis, it's all about the shared surfaces between spaces and the areas of those are the U values. So that becomes very easy to build an energy model out of these types of models that you have here. Again, you can create things like minimum spanning tree. I'm not going to spend some time on it, as well as shortest distances in full 3D. So you can pick any room and say, I would like to go to another space. You can also limit it to rooms that have doors. So you can go room to door to corridor to door. You can say, I don't want to go through slabs, let's say. So it's fully versatile and as you would expect it to be. But that gives you a lot of information about egress. You can calculate where the fire exits are, etc. I talked about closeness centrality. The nice thing about this, as opposed to other space syntax things, is that the kind of visualization, the kind of analysis is still geometrically available to you. So you can still apply geometric operations on it and still get the analysis after that operation is applied. So in this case, I'm changing the shape. I'm deleting a rectangle out of it. And at every iteration, it's computing the closeness centrality. Same thing for between the centrality. This is about the nodes in a graph that get traversed the most. So kind of almost like paths in a park that are traversed the most. They get worn off, and you can see what these are, as well as visibility. What can you see from what point? As I said, I promised a sneak peek into IFC. So we're taking IFC files. This was literally done or completed in a few days ago, basically, and convert them to full graphs based on the connectivity that's available in the IFC file. And you can, again, they're color-coded. They're full of information. You can investigate them and analyze your file that way. But we're here to talk about Speckle. So I was the first, I think, to connect Speckle to pollination. I know there are other solutions now, but this was done a few months ago, if not more, basically connecting Topologic in Blender to Speckle. We have a Speckle kind of API plugin through Streamlit, which is a web-based cloud platform, to Pollination, which is another, obviously, cloud platform. So just let me show you this video really quickly. The full video on YouTube, if you have your phone with you and you're not watching on your phone, you can click that QR code and take a look at this. So this is the Blender interface to topologicpy. Topologicpy can be accessed from Jupyter Notebook as just text, from Dynamo, from Grasshopper, from many interfaces. It's a Python library. C++ underneath, Python bindings on top. It runs on Windows, Linux, and Mac. And Mac Silicon, Apple Silicon. So it's all available. So here you see me getting the building and the windows of the building. And you will see next very quickly, because I know we're out of time. Here is the Streamlit app, where it authenticates to the Speckle app normally, and you get the branches. I know they've changed the names now, but that was done some time ago. And then the files get in. They go to automatically. They go to Pollination. This is me now using my account on Pollination, finding out that the job that I did from Streamlit is now available and running. And then I am examining the daylight factors. So here they are in Pollination directly. No files were harmed. No files were exchanged. It was really all a model from, I believe, from Blender, obviously, but we also have Revit kind of uploading models through Speckle, through topologicpy, whether it's on Streamlit or other cloud platforms or on your own computer, and then creating an HPJSON file, going to Pollination and getting the simulation done. And that is it from me. Thank you.
Thanks, Wassim. You do have a few questions, so I'll just bring them on your screen.
Sure. Let's see. Do you use Ladybug tools to solve adjacency, or you have your own algorithm to do it? Both. We do have our own algorithm to do it, so Topologic can fully solve the adjacencies. But as you know, especially HBJSON and Ladybug tools has, I think it's called like adjacency resolve or fix, or I don't remember what it is, that also does it for you. So we just rely on that and use it. But it doesn't mean that we couldn't have done it on our own, because we have that. It was a bit of an overlap in the API, so we didn't really think that we should do our own, since they've done it and they've verified it. Are we all thinking the same thing? Topologic plus Automate plus Node10. I think we're building on all of that. I was absolutely floored to see the Automate stuff in the morning. I do believe, I mean, we have to have a chat with the Speckle team. Definitely, I see Topologic and Automate come together. NodePen, I am very aware of. I love it. We need to look at, how does it run, how fast, how efficient it is. But one thing we don't have in Topologic is, like a very good, very sophisticated editor, because now we're doing it either through Blender or through Grasshopper or through Dynamo or through Jupyter Notebook, which is the kind of, for us right now, because we are very programmers, it's the best interface. Sorry, I missed this last question. Topology is fantastic. Been following a bit on the side for quite a time as a Ladybug user and hospital planner. How do I get started? So much potential. Space planning, syntax, energy model, walking time for a doctor, energy models, daylights. Absolutely. I am looking for impact case studies. Schedule a meeting with me. Show me your use case scenario, and I'll get you started. There are some videos on YouTube. They're under my name. It's a playlist called Topologic Tutorials. There is a very good, well-documented API. I think the QR code that you see here takes you to that as well. Pip install topologicpy, open up Jupyter Notebook, and start typing. And as I said, have a chat with me about it. I would love to work with you on, especially in the healthcare sector. Does Topologic understand MEP systems? There have been a lot of people using it. That was one of the early stuff. So what they have done is they've taken MEP systems from Revit, took the center lines and the components and the edges, and they're trying to find critical paths and shortest paths. And there are some people doing that. I don't have their names in my mind right now. Sigma, there's a company called Sigma, I believe, Sigma Design. Look them up. Yes, it does understand MEP systems through Revit Dynamo.